So I'm sure that everyone here is familiar with the idea of a spreadsheet. So you know spreadsheets like Google Sheets and Microsoft Excel. The idea is you have all these little cells on your computer divided into rows and columns. Okay, and with and I know that's not the best drawing, but with like Google Sheets and Microsoft Excel, you have the columns are named A, B, C, D, E. All these columns are named with letters, and all the rows are named with numbers. Okay, and this is called a spreadsheet. Okay, in a spreadsheet you can either type text into these boxes, or you can type numbers into these boxes, or formulas. Well, that's all fine and good. Spreadsheets are fantastic. But in today's lesson, we're going to really dive into the original spreadsheets. Spreadsheets that have existed since long before computers were ever invented. And these things are called matrices. Matrices, in essence, they're kind of the original spreadsheets. Okay? And on my paper here is an example of a matrix. And several kind of vocabulary words we need to get out in the open about matrices. Okay, the singular is matrix, the plural is matrices. First off, matrices have, well, first of all, they're determined by these little square brackets. Okay, these square brackets indicate that we're going to be dealing with a matrix. And then each of these numbers inside of here is called an element. Okay, first off, I want to say this. Matrices are generally named using capital letters. So I'm going to give this matrix a name. I'm going to call it matrix L. Okay, now the next thing, so here's a capital L. This is called matrix L. The next thing you want to know about matrices is matrices are a group of numbers or things called elements divided into rows and columns. Now the way we do it, our rows go horizontally. So we would say that this particular matrix has two rows. Okay, a top row and a bottom row. Now the columns of a matrix, these go vertically. So this particular matrix right here, we would say it has 1, 2, 3 columns. Okay, so the matrix that we're looking at right here, it has 2 rows, 3 columns. We would say matrix L is a 2 by 3 matrix. And this right here, this 2 by 3 is called its dimensions. If you're ever asked to find the dimensions of a matrix, you're going to write it as like this, 2 by 3, where the 2 represents, it has 2 rows, and the 3 represents it has 3 columns. A general rule when you're working with matrices is you always want to list, when the order does matter, okay? A 2 by 3 is a lot different than a 3 by 2. Order does matter. The general rule is that the rows come before the columns. I have one of the stupidest ways ever to remember this. Rows before co's. I know that's stupid, but that's something I have said over the years, and students remember it. Rows before co's, meaning rows before columns. Okay, now the last thing we want to say about this matrix, matrix L, L has 6 elements. Okay, all the numbers or things inside of a matrix are called elements. We could list them out: 4, -2, 7, 10, 0, 11. This is kind of like the set of the elements. Just like a set has an element, so does a matrix. Now, you can actually name each of these elements individually like this. So let's say I wanted to name this 7 right here. I want to give it an individual specific name. What I do is I would write a lowercase l. I'm going to write kind of like a cursive L because so you can tell that it's an L. And then look at this 7 here. 7 is in the first row and it's in the third column. So what we do is we write a lowercase l, and then in subscript we write a 1 and a 3. Now sometimes I've seen a little comma separating these two, but a lot of textbooks don't even put a comma. Lowercase l 1, 3 is equal to 7. That's how we could name a particular element. Or I could do it in reverse. I could say find L21, and you would go to the second row, the bottom row, and to the first column, and the answer would be 10. Okay, so all this vocabulary, what is a row, what is a column, what is dimensions, how do you list the elements? This is all the vocabulary associated with a matrix. Okay, now what we want to do next, now to end this lesson, let's look at how we would add or subtract matrices. Okay, so here we have 3 different matrices called A, B, and C. All right, and we're not asked to find the dimensions, but we certainly could. This first matrix has 3 rows and only 2 columns. This would be a 3 by 2. And here is its 6 different elements. This one is the same size, 3 by 2. Now this last one, you can actually have a matrix that only has 1 row or 1 column. This particular matrix has 3 different rows, but only 1 column. Now remember, it's rows before columns, so that would be called a 3 by 1. All right, example number 1, we need to find 4 times A. This 4A means 4 times A plus 2 times B minus A. So let's start with this. How would we do a 4A? Can we multiply a number times a matrix? And the answer is that we can. I'm going to kind of just on a separate sheet of paper, if we're ever asked to take a number times a matrix, like 4 times this matrix A, it works very much like the distributive property. What we do is we're going to multiply each of these elements by 4. The top row would become 4 and 16. The middle row, I would kind of distribute this to 4 times 2 and 4 times 5. It would become 8 and 20. And then we distribute this 4 into the bottom row. 4 times 3 and 4 times 6 becomes a 12 and a 24. So multiplying a number times a matrix, this is called scalar multiplication. It works very much like the distributive property. We're going to multiply all these elements by 4. So with that in mind, we're asked to find 4A. Okay, we're going to multiply all of these elements by 4, just like we did on the back page. 4, 16, 8, 20, 12, and 24. This is 4A. Now we have to do 2 times B. So plus 2 times B, I'm going to double all of these numbers, times each of these numbers by 2. That would leave me with 14 and 8 and 16 and negative 6 and negative 18 and 4. All right, hopefully you are good at doubling or tripling or quadrupling in your head. All right, lastly, we're supposed to subtract A, so that this A is just going to stay the same. Okay, so we did our scalar multiplication. What we need to do now is do an addition and a subtraction. So to add 2 matrices together, all you do is you add the corresponding elements. So to take this first matrix times the second matrix, I'm literally just going to do 4 plus 14, 16 plus 8, 8 plus 16, 20 plus negative 6, etc. Now I'd also have to subtract this last matrix. So I'm going to actually, I could certainly break these into separate steps and do it like that, but I'm going to actually, you know what? I'm going to do all 3 of these matrices, combine them all together. My first element, I'm going to take the 4 plus the 14, but then minus the 1. 4 plus 14 minus 1, that comes out to 17. That's going to be my answer in the top left corner. Okay? To find my top right answer, I'm going to take the 16 plus the 8 minus the 4. 16 plus 8 minus 4. That actually comes out to 20. So I'm going to write that answer in my top right column. And so using this logic, to find my middle row, first column, I'm going to take the 8 plus the 16 minus the 2, and that comes out to 22. To find my middle row, second column, I'm going to take the 20 plus the negative 6 minus the 5, and that comes out to 9. Okay, now my bottom row, I'm going to take my 12 plus my negative 18 minus 3. I'll write out the steps if that helps you at all. Okay, this answer is going to be, that'd be negative 6 minus 3. This would be a negative 9. Okay, my bottom right answer, I'm going to take the 24 plus the 4 minus the 6. That'd be 28 minus 6. That is 22. 24 plus 4 minus 6. Okay, I know I didn't show my steps in the middle, but that's the general idea of how you find this. This is my answer. This is the answer to 4a plus 2b minus a. And there I wrote in the steps for the middle row too, because I didn't want them to feel left out. All right, so this is how we add and subtract matrices. You just add or subtract what's called the corresponding elements from each matrix to get the new element. All right, example number 2, our last example, find b plus c. All right, here we're supposed to take 7, 4, 8, negative 3, negative 9, and 2, and add this single column 7, 6, 5. In other words, here I have a 3 by 2 matrix. I'm trying to combine with a 3 by 1 matrix. So how do we do this? How do we add matrices if they're not the exact same dimensions? The answer is you can't. Okay, this is impossible. Only matrices with identical dimensions can be added or subtracted. And I'll write out that little note here so you can see it. If you ever try to add or subtract two matrices that are not identical, completely identical in dimensions, not possible. See, everything up here was possible. Everything up here we had a 3 by 2 plus a 3 by 2 minus a 3 by 2. Okay, all those dimensions matched, so we were allowed to add and subtract these together. But if you ever have a mismatch of dimensions, we're just going to write impossible or undefined. Okay? All right, so best of luck on this assignment. This assignment's going to have a lot of vocabulary. Okay, you can look back up at the top here for help with the vocabulary. And it's going to have a lot of addition and subtraction and kind of distributing and multiplying. So all I would tell you, I don't think there's anything particularly hard with these examples. Just be careful. The slightest little mistake can lead to a wrong answer. So really just take your time with this and be careful with your calculations. I wish you the best of luck. Take care.